All right, so this is meant to be a 30-minute introductory webinar introducing InfraGuard, which is now available outside of the UK globally. This is definitely mostly looking at the list here, North American people, so that's good. So good morning is appropriate. On the right-hand side, I think most people by now are pretty familiar with GoToWebinar and how it operates. There is a handout on the right-hand side if you drop down the handout menu with our brochure. There's also a video that we'll share in chat at some point. And then if you have any questions throughout this, please go ahead and plop those right in there to the question section, and I can address those at the end. So again, InfraGuard with Senceive. My name is Dan Miller, for those that don't know me that are on this list here. This will be a quick 30-minute session introducing InfraGuard, very high level. We'll go ahead and run through, where's my introduction here? So infrastructure asset management, right? Defining that, defining the risk, the type of assets that we do like to monitor or deploy some sort of risk mitigation program upon. Then, of course, what is InfraGuard? How does it work? So look at some of the technical aspects of the solution, a handful of case studies, and then we'll wrap with a summary and Q&A. So I will certainly keep it snappy to remain within that 30-minute time frame, which sometimes, well, most times I actually run over, but let's go ahead and jump right in. So let me just adjust my screen here so I can see the full thing. Okay, so first starting with infrastructure asset management. Sometimes this bathtub curve is used to help define the failure rate, which we're seeing here in the y-axis. So that's the hazard rate, the likelihood of a asset to experience some level of failure against time, which is on the x-axis. So starting with earlier failure, sometimes called infant mortality, there can sometimes be a high level of hazard or potential failure to a structure, which is normally due to design defects or construction. Next will be random failure. This is definitely in the mid years of design life of a structure, where there certainly is a very low failure rate. Failures could be random due to some outside influences, earthquake or potential design mistakes during construction. And then end of life. So this is something that we're all very familiar with here. I see the names on this list. Aging infrastructure is certainly a hot topic right now, certainly in the US. Bridges, tunnels, certainly railroads are all experiencing, varying levels, increasing levels of, maintenance and monitoring, certainly risk mitigation programs being deployed on different structures, as more and more of our infrastructure is, well beyond its design life. So a list of, assets with high risk failure and certainly impact. You can see some photos here on the right. I'm sure a couple of these are familiar. On the left-hand side, just a list, including but not certainly limited to embankments, cuttings, retaining walls, rock falls and landslides, open pit mines, of course, and then dams, levees, and bridges. These are all areas that certainly have a high risk of failure and impact if there was failure. So further defining an asset risk, this is a common table used to categorize, according to the x-axis, A through E, and then the consequence of that hazard event, 1 through 5. So looking at, box E5, that's certainly a structure that would be of grave concern, likelihood of a hazard event, very high, with the consequence of that hazard event. And then further categorizing the risk to infrastructure with some general, monitoring or inspection methods. Low risk, we'll certainly have a yearly or visual inspection and examination of that structure. Medium risk, there'll be a higher frequency of inspections. There may be some geospatial, optical type monitoring maybe some remote monitoring technology, but really set up, really as background gathering data for long-term information. And then our high-risk infrastructure, where there certainly is a higher level of remote monitoring, live alerting deployed on these assets, certainly with emergency preparedness plans in the case of failure or movement. So furthermore, looking at, after a high-risk asset is identified, the most reactive monitoring methods, moving to the least reactive there on the right. So the most reactive, of course, is having, someone on site, but that is certainly, unsustainable for long periods of time. There are always-on sensing devices, which require mains power. Normally, those are power-hungry systems, expensive to install and to maintain. And in the middle here, we have the intelligent monitoring solutions, which we can call them. These are long-term remote monitoring technology that do not compromise the effectiveness of that technology, while also having very long life, low maintenance capabilities. Next one, moving to usually asleep sensing devices. So these are what I call more reactive type monitoring technology that is deployed and is really just taking readings on preset intervals and gathering data to identify long-term movement, creep of a structure, if you will. And then, of course, manual monitoring, which is the least reactive, data gathering, bring it back to the office, analyze it, which all takes time. So, of course, right, getting to it, what is InfraGuard and where does it fit? So this would certainly fit in the intelligent monitoring solutions. If you could guess, that's what I was getting at by having this one right there in the middle. What InfraGuard does is it expedites alarms. It can trigger other nodes or other equipment that is on site to take readings in the event of movement captured at any time. It can account for that sudden movement with visual verification. And it has the capability for dynamic and live reporting rate. Essentially, the more a structure moves, the higher that reporting rate can become, and that's all preset on the nodes themselves. So looking at a little bit closer here. So with InfraGuard, there's really two key components of this system, of the hardware. InfraGuard itself really is a suite of features, a management tool that sits on top of the hardware and sits on top of the communication network. And that's really what manages all this intelligent action that does happen on site once any movement is detected. So those two key components, starting first, of course, with our tilt node. This is the Nano Macro tilt node on the bottom right-hand side. This is installed on our stake mounting kit. That node is sitting there vertically. And then on the top photo, we have the camera system being installed. So the camera itself, you can see in this gentleman's hands right there in the middle, being controlled by our Edge Hub device, which is battery powered, rechargeable via a solar panel for complete remote installations, autonomous operation, no human intervention required for the system to work, as we'll get into here. So a little bit more on the camera itself. So the camera is a low light 4G LTE enabled camera device. It does not use any illumination to capture images or to illuminate, to be able to capture images. These are actual photos from a live site, of course, a rail site. In the foreground here, the bottom of the left-hand side picture, you can see a node mounted on a stake. And along that cutting, you can see them mounted there along this track. In this case, of course, monitoring that cutting, that slope for potential failure or movement closer to the right-of-way of that track. So it's a midday shot on the left-hand side, and then it is a midnight shot on the right. So very similar, certainly can see the asset, in this case, the track that the camera is pointed at. Again, without any illumination required. The camera uses ambient light to collect and create this image. These images are high quality, they're high res, they're a little over 3,000 by 2,000 pixels. And again, this camera is Senceive's product. This is our proprietary technology. So all of this sits and operates, thankfully, to our FlatMesh technology, which the FlatMesh technology, again, is Senceive's own proprietary mesh technology. It's a 2.4 gigahertz radio communication. We control and can upgrade and manage that, which allows us to do very market unique things like InfraGuard and the actions that it can take on site, which I'll dial down to in a couple of slides. So FlatMesh, if you're not familiar with it already, is a mesh network. It's a repeater network, you can say, where all nodes on a network, can communicate with one another at a very high rate. So sampling rates we can get sub-minute on all networks, and that's where we really see this fast reaction if there is some movement to when an alert and data is received. So even with this happening, it's very important to emphasize that we still keep a very low power draw on these nodes, where we can still maintain years of battery life, even with this very reactive system operating, because it's only triggered to take action and to increase these sampling rates and data transmission if there's movement. If not, the system sits in the background and monitors, on these preset intervals, only reacts and takes more action, drawing more power if there is some action on site. That is the unique intelligence that Senceive does have. So on FlatMesh, we also allow remote upgrades and configuration. This is a very quick and easy two-way communication platform, which does provide, along with all of this, data and reaction, on-site health management. So that's simply, voltage information, temperature information, signal strength, uptime, all of that is available through the software management platform. So looking at the alarms and the expected latency after a tilt node is triggered by an event. So in areas that do have good cellular reception, so think, if you can load YouTube, watch a video, that's going to be good cellular reception. We see from the moment that a tilt node is triggered by an event to when alert is received is about 60 seconds. And this pie chart here is breaking that down, the different, normal time frames that each action takes. So the first here being the tilt sensor sampling, next being the FlatMesh network propagation, so that's sending the signal, from node to gateway device. The bulk of that time really is going to be the cellular latency, and we say, that's the majority of the 60-second time period. And then the web monitor processing, so the software to take that information, process, and issue alerts, a very short period of time. So that gives us this 60-second, which we do have tested, globally. Certainly here in the US and in Canada, we are seeing 60 seconds, even less than 60 seconds in some areas. But always important to test this sort of thing before deployment. So the most key feature I'll say here really is the sudden movement detection. That's what we're happening. That's what we're taking advantage of here with this unique offering that Senceive has, is for a node to detect movement at any time. So not when it's set to take sampling rate, like every 30 minutes or every hour. It checks if there's been a change, it sends an alert. Once that data gets to the software, the node is programmed locally to detect movement at any point in time if there is a movement beyond 1 degree per second. And there's multiple thresholds that can be programmed at each node level. The programming can be done locally, but also, and most importantly, can be done remotely through our software. Network triggering, another key feature, very key feature, I'll say, is the ability to trigger other nodes on that network if one node does detect movement. So in this example here in green, you can see all nodes are stable. They look vertical in the photo. The little green here indicates that. The second one would be, one node detects movement and it triggers an adjacent node to take a sample. And the third case is movement beyond another threshold where it triggers all nodes on that network to take a sample. So all of this is preset, pre-programmed, and defined by each user. There is that flexibility to do that, and all of that is done through Web Monitor. So looking at this dynamic sampling rate and the ability of the sampling rate to increase depending on the severity of movement, we use this little chart here to show this. This is actually something that you can see on Web Monitor when setting up your alerts, is this chart here on the left, give you a visual of what's going on. Essentially, starting at 0 degrees, which we would baseline that node's position prior to enacting these features, you can have plus or minus, whatever that threshold is. So looking on the right-hand side, for example, we can set up a system to report every 1 hour, but we can certainly go much less than that. Just depends on what that requirement is on site. We can go sub-minute on our FlatMesh platform. In this case, looking at a 1 hour sampling rate, which is certainly sufficient, because what's important here is if there is movement, we're going to capture that, right? So we don't have to operate at a very high sampling rate with this system. So in this case, we're saying, minus 8 degrees or plus 8 degrees, keeping it at the same rate, giving a yellow alert. If it moves beyond that plus or minus 20 degrees, increasing that to 15 minutes. And then beyond plus or minus 40 degrees, increasing that to every 5 minutes. So this is a very typical way of setting this sort of thing up, something we always ask a customer before they're doing it, or we enable a customer to do it themselves when providing the service to an asset owner. But this is a very flexible, easy to use tool on our software platform. So bringing this all together with a video, I'm sure some of you have seen this already, it's been around for some time, but to summarize everything I just said, I'll let this play out. So we have a system set up to monitor a slope. We see that failure right there in the middle of the screen, in the middle of this array, which triggered the camera to take a photo. Further movement does request another photo to be taken, and you can see that on the top right. So of course, all this is going to be time stamped to allow that correlation to be done on the back end on the software, looking at the time of the data, looking at the photo, giving that visual verification of what is happening on site. So this video's animation we have right now is, of course, on a cutting, doing slope stability type monitoring. You can imagine those other application areas that I summarized earlier where this technology could certainly be used. Essentially what we're doing here is monitoring something long-term with very low maintenance, low power, long life sensors, and capturing movement at the point of when it does occur and communicating that through to a user with that data and with that visual verification. And on that note, so something that happened really just about 5 days ago on a railroad, nondescript, I won't say the location, was this occurrence here, this situation. So starting on the bottom right-hand side, we can see a photo. You can see some tilt nodes. It's a solar panel on the right-hand side monitoring this track location. Just set up for time-lapse photos. That time-lapse is user adjustable. Right now we're looking at a time-lapse showing a 1 p.m. shot, then moving clockwise from the bottom right-hand side to the next photo, a 7 p.m. time-lapse shot showing all clear. And then right before midnight, we see a Land Cruiser came off of the slope above the roadway and really just drove right through some of these nodes and then triggered all these actions to happen. So increased sampling rate, photos to be taken. You can see 11:48, 02 seconds, there's a photo, 04 seconds, there's a confirmation photo. About a minute later, there's another photo. And then right about 3:30 a.m., you can see some workers on site. They're there, of course, to clear that car before the morning trains are meant to come through. So 7 a.m., you can see track clear. And then moving into later in the morning, you can see, of course, all this debris on the ground, maybe partially car stuff, but certainly stakes, nodes, solar panel, you can slightly see right there above that 26, and then more photos going on through the day. So, a system that was really just monitoring, at preset sampling rates, would provide some information, as long as that monitoring frequency, was short enough to capture this situation. But that data, is hard to, really, surmise depending on what sort of system you're using, the concentration, cluster of sensors, sensor types that are on site. Having this reaction, having this visual verification is really what indicated to the operator here, there was a concern that they did need to deploy, they did need to go on site to remediate the situation. So some case studies, I'll run through these. Network rail, certainly the biggest deployment worldwide of this technology. The Network rail southern route, 24 miles of this rail asset, has over 10,000 tilt nodes deployed along the slopes, 500 plus cameras and 200 plus gateways, all managing that situation which we saw before. They have a lot of issues with their Victorian era cuttings where they are failing. So there was a very big buy-in on this by Network Rail because they really saw the advantage of having this remote monitoring technology, the visual verification, all without having to have inspectors on site all the time. Some companies, some asset owners, use this and look at these very widespread deployments or really concentrate it, in certain areas along their asset. So an idea of that here is here in Washington State, we have a project along a section of highway. There's been some ground movement, some landslip occurring. You can see in the right-hand photo here that this highway is cracking and sliding away down this slope. So what they went ahead and deployed the InfraGuard solution, and it was a series of the Nano Plus tilt nodes, one of the tilt nodes that we do have, mounted in the crack in the highway, on the slopes along that section of highway, and then above the highway itself, to be monitoring that near real time. Whenever there was a heavy rain event, they saw movement. We were picking up, inches of displacement along that slope and along these cracks. What they did do is they kept one lane open on the high side of that roadway, and having this technology in place gave them the confidence to really prolong the life of that section of highway before having to come in and provide any remediation work while allowing traffic to run through that area confidently. International example, Austria. So this is a good example of a construction area with an active sliding slope above. There's a lot of work gone into this sheet pile, board piles, and anchors to stabilize that, and a full instrumentation scope deployed here. Not just Senceive's solutions, also there was some manual monitoring, robotic total stations, and some in-ground instrumentation like inclinometers and piezos to really get a good feel of what's happening, not just at the surface, but also at the toe of that slope subsurface. So what's great about this project and these photos that we do have is really emphasizing the point that the nodes don't need to be installed just on slope, just on stakes. They of course can be installed on other structures. So we see here, on the first photo, a concrete block, the second being a sheet pile, and the third being an anchor beam. And a camera was included on this project and did pick up movement when that was indicated. And this is a comparison of that data. So on the left-hand side, we have a screenshot from Web Monitor. If you're familiar with it, you can spot that. That is the tilt sensors on stakes showing successive movement while this project was going on. And then on the right-hand side, we have prisms, which are being monitored by robotic total station. You can see there's a very nice and tight correlation between the tilt nodes and the prisms. You can see in the middle photo here, there were prisms in a lot of areas installed to complement what the tilt nodes were doing on this project. And that verification of that movement can be seen between the two. So getting close to summarizing this and wrapping it up. So, what makes this solution so special to asset owners is really having confidence, really, in three main areas, that any changes in the asset's behavior will be captured. So, you'll be gathering that data, certainly, but having the InfraGuard solution deployed on that asset really is going to, instill that confidence that any breaches beyond thresholds will be expedited, right, to the right people, to the people managing that asset or this project, with increased data flow, but also that visual verification, and also the confidence that this information is being acted on and is reliable. And really, that a lot what ties back to that is reliable is the increased data flow, so those decisions can be made confidently with more data and all that data is happening, happening automatically, that increased sampling rate, but also, right, having that visual verification, which is priceless. So, right, for all those reasons, InfraGuard was developed. It has been a little over 4 years. This has been in play. So there certainly is that experience and expertise that comes along with understanding, the pain points of asset owners, of the consultants and contractors and monitoring specialists who work with them. That feedback is what, Senceive takes and further develops and, improves the technology. It's having technology itself, and then it's having, really on a combination of not just Senceive, with our very experienced engineers and technical staff and, business development professionals, but also the partners and companies that we work with, are all there, installing, maintaining, and, monitoring assets with this technology. So high level introduction. I think I kept within that time frame. And I didn't lose you, did I?
No, still there.
They're still there. All right, great. So we have some questions here. Please feel free to throw some more in while I'm running through the list, and I'll jump in. So first question, do you need both the Edge Hub and the gateway to complete the system? So yes, it's a good question. So the FlatMesh gateway is what manages the entire system. So that sits above everything. So that's what manages the communication from node to node, node to gateway. That needs to be in place to trigger the Edge Hub device, which controls the camera. So you need to have both of those on site for each system. Is there a limit to the number of tilt nodes that can be deployed on a network with InfraGuard features? So we always recommend up to about 75 nodes per gateway, per network, be deployed in one FlatMesh system. And that's really to allow a balance of 25 because our max limit per FlatMesh gateway is 100 nodes. So normally 75 nodes on one system is what we recommend. What else do we have here? Are the tilt nodes a Senceive product? So yes, absolutely. So everything I just ran through are Senceive products, Senceive solutions. So if you're not familiar much with Senceive to a different level, Senceive is a manufacturer. So we manufacture the hardware, the software, the gateway devices, everything that you saw are Senceive products, Senceive solutions. Senceive does not provide installation services, just furthermore. But what we do is we sell and we support. We leave the installation and management to the monitoring professionals. So the question here, what's the cost of deploying the system? It's very reasonable comparatively to manual inspections. It's very reasonable compared to a lot of monitoring technology on the market. Certainly happy to run through that a little bit more detail, so I'll follow up with you after this. Thank you for that question. So another question here about the photos. Can the photos from the cameras be sent automatically via text emails? So right now, what we have is the alerts, the data alerts coming through via email and SMS text message. When you get those messages, you're prompted to go to Web Monitor, and that'll bring you there automatically. On Web Monitor, you'll have a photo gallery where you can make that correlation. Everything is timestamped between the data. Right now, the photos won't come through to text and email at this point. Thank you for that question. And then another question about solutions for areas without self-service. Yes, we do have solutions for areas without self-service. Can certainly happy to follow up with that and talk about those options with you. Another question, are there examples of the system deployed to monitor bridges or other structures? Yes, certainly. I ran through just a few examples here, but we do have other examples where this is deployed to monitor different types of infrastructure or structures. So I can follow up and definitely run through that with you as well. Another question coming through, does reporting rate affect battery life? So yes, certainly reporting rate will affect battery life. What our batteries have on the nodes, as far as the specification goes, is 12 to 15 years based on a 30-minute sampling rate. We really only start to affect battery life once we go 7-minute. So really at 1 minute, 5 minute, 10 minutes, we still have many years of battery life. And that's the beauty of the InfraGuard solution, is you don't have to be monitoring it every 30 seconds, at every 2 minutes, every 5 minutes. The node will react if there is movement and then increase that battery life. But even in that increased battery life stage, which is only temporary to capture that information, that's then dialed back once the risk is assessed. You'll still have very long battery life in the years when we're talking about minutes of sampling rate. Let me see, run through the list here. Just getting over the 30-minute mark. Yeah, we'll certainly share a copy of this presentation. I believe a video will be sent, recording of this video will be sent out if you did register for this, so you will definitely get that. Remember, there is a handout also on the right-hand side to download our brochure. And in the chat, there is a YouTube link to our marketing promotional video, which probably describes it in much higher fashion than I did for you today. Last question I'll take here, would Senceive be able to assist with getting an installation up and running for a first-time user? We certainly can explore case by case. New time users, we can introduce a monitoring expert, who would be a customer of ours, who is, well-trained and, knows how to use our technology to do that. We are very involved with customers directly also, at a high level of, commercial, technical involvement where we can certainly provide training to our customers. So yeah, all right, well, I'll close it there. Thanks for joining, and I hope that was informative. Again, you will be receiving a copy of this recording, and don't forget to copy or download that brochure and click that link to YouTube. So thank you very much for joining today. Thank you.